Hello everyone, it's been 2.5 years since my last tutorial video, and I thought why not make one now. So here it is, because I have a door that I want to build. So this is a 5x5 Seamless Deep Vortex quote-unquote vault door, which is originated from a door concept from G6W9 in one of his submission for an event. And I basically improved upon his door to make this entire door full sync. And what I mean by full sync is that basically every single block you see in the hallway retracts or extends in unison. So let's just see the door working. So yeah, you can see basically every block is in sync. So if we, slow down the game for a bit. So you see the first block in sync, second block in sync. And yeah. And the covering pistons are also all in sync as well. So that's also really nice. And the opening would be the same. So you can see the first block in sync. The second block is in sync. And yeah. So that is what it means by full sync. So yeah, I'll do the tutorial while explaining to you how the door works. So let's get on to it. So let's just see the materials first. These are the materials you need. For the end rods, you can basically replace with any transparent blocks, however you like to decorate it. These are repeaters, these are droppers, and yeah. Rails can be the same actually, but then I just like to separate it for convenience. And an optional item, if you want, you don't necessarily need to have it, but I prefer it. So yeah, and the dimensions are 13 by 13 by 4, so 3 on each side basically. So let's build the layout first. Now, a deep vortex door is actually very similar to a standard vortex door, but even though it's similar to a vortex door, even vortex door itself is actually kind of complex. So let's just build it from scratch. So the easiest way to describe how a vortex door is created is by using one of its close neighbors, the funnel door, to establish it. So you want to have a funnel door like this. You push these 4 blocks back, and then you push these 4 blocks back. And for the deep vortex door, you also want to push the middle block back as well. And now at the front, you will see some holes here. So all you need to do is just to cover them to make it, such that you cannot see the other side. And bam, you have a deep vortex door in this case. And for the vortex door, just have this instead. But since we are doing a deep vortex door, we will have something like this. And the reason why it's quote-unquote a vault door is because we can add some decorations to it. So for this door, there are 4 extra blocks. So these are the 4. And yeah, the original door uses end rods, so I'll just use end rods as well. Because why not? Looks nice. So now we have this in place, so we can create our piston layout. It's actually quite simple. So regarding this is basically a glass block. So we are going to pull it down by a double extender like this. And we also need to remove this block, so we need some covering pistons like this. So how it works is pretty simple. Retract these 2, then do a double, and then push these 2 back, and we are done. And for the bottom right, we need this extra piston, which will be apparent later. And since this door is rotationally symmetrical, this means that all the singles, doubles, and the end rod doubles are going to be symmetrical rotationally. So we will have 5 singles like this, so we can remove them as we place them. So to mark it. And then for the doubles, each side is going to do 2 of them. And the 2 of them are going to be the easiest, of course. So we are going to do this 2. We are not going to do this one because there's already a single here. And if we want to do this additionally, we'll basically need a semi-hipster. And that's not the thing that we want to do. So we are going to leave this to the other side. And this applies to all 4 sides. So each side is only responsible for 2 doubles. So yeah. And now to build the rest of the layout. Same thing, basically. Then we have the doubles. And for the triple, we are actually going to have the top to do it. It's by far the easiest side to do it because we can use quasi-connectivity to control the bottom piston. So that's our piston door layout finished. Now, after completing a layout, well, you basically need to plan for this door. There are 2 things. Firstly, because this door is meant to be full sync, so we need to consider the timings. The second thing is, of course, the inputs to the pistons. And I'll start off by explaining the timings first. So the timings for this door is actually quite simple. First, I'll illustrate, the simpler ones. So we are now going to ignore the triple and only focus on, singles, covering pistons, the end rod double, and the normal doubles. So when you see these numbers, so say, this is 2, this means that we are going to have a 1-tick pulse, so an observer, to power the piston at 2 ticks here, or 4 game ticks if you're using game ticks. Multiply by 2 for, game ticks. So 2 really means powering from 2 to 3. So we power at 2, but we unpower at 3. So yeah, just add 1 to find out when we unpower it. So there you go. And while we're here, we should also explain why the first move, which is this here, is 2. The reason is due to this. Because you can see this double, it doesn't really have much space to fire the top piston at this level. And don't get the illusion that we really have space here, because in reality, it will be something like this. And we still need to power it, so we can power via this solid block, but it would interfere with this piston. So this is also a reason why we need to pull it back. And we're going to have an observer here, basically. So this observer is going to do both the powering of this piston here and also the powering of this covering piston. And if you're going to need a very speedy door setting, you would, you can have a zero tick pulse, or not really a zero tick pulse, just a pulse that instantly goes to this line here instantly. But I decided I'm not going to do that because you still need to wire to other places at the same time. So instead, I'm just going to add one more tick of delay, just generate a one tick pulse from an observer. So a simpler solution. So that's why the first pulse is decided to be at 2 ticks. And then every single move afterwards is going to work in increments of 2 ticks. The reason is also quite simple. This is to ensure that every single piston move is going to work fine. And it's also quite intuitive. So you can basically remember when it's going to fire instead of remembering specific cases. But yeah, either way. So we have 2 here, and then we'll have 4 here. Then we have 6 here, and then 8 is both the singles and this end rod double with the front piston. They're both going to extend at the same time because we need full sync, right? So yeah, both of these are going to extend at the same time. And meanwhile, we also have this here, the double, the back. We are going to power the dropper here, for example. We are going to power this at 8 as well. So to make the first move of the blocks in sync. So yeah, anyway, so after that, we'll have 10 here. We also have 11 here. We don't care about that now. And then we have 12, it really does nothing. And then 14, this push up, 16 goes back. And then for the opening, it's the same thing. So 2, 4, goes like this. And then 6, but then this time you see the doubles is at 7. The reason it's at 7 is also quite intuitive. The block is now at here. So these doubles are relying on this observer, which is at 8 now, to retract. So we basically need to make sure that all the front pistons retract the block at the exact same time. So hence, it will be the doubles that will fire early to make this front piston retract the block in unison with the singles and the end rod double front piston. So that's why it does that. And you might be thinking, instead of having double that would reduce the delay on the opening, we can instead have the double at constant delay and somehow manage to have all the singles and end rod double extend the front piston to have different delays. So say this will be at 8 for both cases, and then the singles will be at 8 during the closing and 9 during the opening. And while this works, you also need to realize that there are a lot of singles that you need to fire. Doubles, you really only have one input location. But then for the singles, you have multiple, and all of them have to requires an offset circuit. So it's not that feasible. So instead, it will be better for us to have the offset circuit at the doubles instead of at the singles. So that's why the singles are constant delay, but then the doubles, the back piston, they're at different delays. And also notice that the doubles here, there are 2 pulses, so 8-11 versus 7-10. Both of these are 3 ticks apart, which suggests that we can do observer, resonant lamp observer, which creates the 2 pulses at 3 ticks apart. So yeah, anyway, so these are going to retract. Then we have 10, 12, and then we have 14. This goes up, and then 16, like so. So this is going to be the timings for all of the 4 sides, basically. So yeah, and one more thing to explain is I guess why is this at 6 and this is at 8? Because when you see the doubles, this is like at 8, but then this is at 9 during the closing. So why the doubles, I decided to, just have 1 tick delay apart, but then here it has to be 2 tick delay apart. And the reason is actually quite simple. If we decide that we will have 1 tick apart, the thing is, this end rod can only be pushed 3 game tick after the initial extension. So even though the front piston here, so say this power at 6, this front piston here can extend at 7, the end rod cannot. It can only be pushed at 7.5. So this creates odd game ticks. And it's probably not what we want, because if we want this to be full sync, we also need to control all of these pistons at 7.5. So that's not what we want. So instead, it is much better just to leave these two ticks apart. So yeah, that's why that's that. The end rod doubles have to have this back and front piston to be 2 ticks apart. And the difference between the end rod double versus this normal double is that for the end rod double, we are concerned on the second part of the extension. So we are concerned on this extension. We are not concerned on this extension. While for the doubles, we are concerned on the first extension, not the second extension. So we are concerned on the back piston. So that's why we can accept just having 1 tick for the front pistons, but we cannot accept, a 1 tick delay between these 2 pistons. So yeah, hopefully this makes sense. And, to illustrate how we are going to do, this 8 versus this is close 8, 11, open 7, and 10. We can use this module to explain it. So let's suppose this redstone line is going to be powered at 5. And this reconciles with our previous timings to that this single is going to power at 8. Now, how do we control the doubles then? We basically need 1 extra delay, 1 tick extra delay for the closing. And we do it from here. Since this last line is going to be fired by a 1 tick pulse, this also means that this piston has to wait until this line turns off to retract the block, which is the extra 1 tick delay. So here it would be 5, So 6 is called, so add 1 caused by this here. So 6, 7, and 8. So we have this being in sync. Now the opening, this is still at 8, but then this would be at 7. The reason is because this dust line will fire this piston, but then this piston extending the block can be instantly received by this observer. So, 5, the observer has 1 tick of delay, so 6, and then 7. So we will have this instead. So that's basically how it works. And for the retraction of the double, I haven't really mentioned it. Now, the retraction is actually the same delay as to this here, which is 12. So this is also 12. And we can achieve this by hit. So this is 8, right? So 9, 10, 2 ticks of delay, 11, 12. So 12 it powers here. Now you can notice that this has a toggle here. The need of a toggle really depends on the location of the double. Because for some doubles, for example, the side double, you are going to power the piston, for example, at this location. And powering it at this location has the benefit that it does not interfere with the back piston. It does not interfere with the front piston at this level. So no toggle is fine. But then in cases like this, it is not fine. And this is also in conjunction with where you are taking the outputs. If you're taking an output, say from this offsetted delay, then it's fine. But then if you are taking an output from a no offset circuit, then it's not fine, because it would interfere here, as an example, with the bottom piston, and it will cause the retraction to fail, basically. So that's why a toggle is sometimes needed, sometimes it's not. So there you go. And you realize that I haven't even touched on how the triple works. So let's just examine that now. The triple is actually quite reliant on the double circuit. So the double circuit, this is a prototype, it's not the actual circuit, but either way. So we have the same thing. This is at 5, and then we have this offset, as you see already at the bottom. So 6, 7, 8 during the closing. And because we need 8 to power all the all the first extensions, so the natural choice would be, besides powering this double, we also need to fire the back piston of the triple, which makes quite a lot of sense. So all of these are going to be in unison. Now, after powering this, we have a problem. The problem is that we decided that the double is going to be connected directly with just one tick of delay. So what happens is that this double here will fire at 9.5. The reason it's 9.5 is quite similar to the previous explanation for the N-rod, why it cannot do one tick intervals. It's because this block here can only be pushed at 9.5, basically. So even though this piston can push at 9, but then it'll still need to wait for this block to actually be able to push. So 9.5 of this here. So we see our problem already. We cannot allow this middle piston to extend. Or we can, but there will be another problem. But either way. So this piston is going to extend at 9.5 and retract at 10. And while we can, time the middle piston at 9.5, it actually still doesn't work. The reason is because remember that this piston retracts at 10. This means that this block will be spitted out with a 1 game tick pulse. But then if we are going to spit this middle piston instead for the triple, then what happens is that this block will move at a normal speed. So it will move at a 2 game tick speed, basically, instead of a 1 game tick speed as to here. So we cannot have that because, so one of the things you need to notice is that besides the timings have to be exactly the same, the animation also has to be exactly the same. So that's the core of full seamless. So this is one thing that you should notice when you're wiring doors that require sync. So yeah, so that's why we cannot have the middle piston fire, even if the timing is the same as this here. So hence we need the front piston to fire, which this dust here can actually achieve that. Because what happens is that if you recall this location, so basically this dust, 1 tick after, it will fire this dust. So this timing is the right timing for racing condition, or if you don't like this term, you can just call it piston priorities. And it suggests that the front piston will fire instead of the middle piston when they're both fired at this timing at the same time. And also, fortunately, this piston will give reliable block updates to this piston, such that even though this piston is bothered by this block here, it will still be reliably updated by the double front piston. So hence we end up with this. So this retracts at 10, and then we just basically have to time it such that, do something like this. Let me remove these because it's a bit confusing. So yeah, let's just demonstrate it with circuit like this. So to give you an idea of what this is going to do, I also incorporated this little circuit here, which is going to be useful. I'll explain it in a sec. So you see, this circuit, what it does is that after the extension, this pushes at the same time as this here. This will push, but then it will retract back. And we don't want it to retract back. So we basically just need to time it at the poles such that it will do this. So yeah, so that's the plan. Now notice this, notice the opening. So the opening, what it would do is that there will be a pulse that would fire here. So I'll just do this now. Then if I do this, now it seems that there's nothing really special, except that it's just the middle piston retracted and then the middle piston dot pulses, tracks and extends it back. But then the special thing is actually the interaction between the top and the middle piston. So look at this. So you see that the middle piston is not getting grabbed by the top piston. Whereas if I use an observer here, things will get different. You see it gets grabbed by the top piston. So this circuit is important for two reasons. The first reason is for the extension. It provides the pulse required such that after the derp here, this middle piston will also have a pulse here, basically. And also the second pulse, like the pulse that retracts this, is actually due to this dust here. I'll talk about it later. And the second important thing is that this circuit also prevents the top piston from retracting the middle piston. And this is due to Tautic priority. Now, if you notice, we powered this redstone lamp with this piston here. We are having one tick here, so this powers from 1 to 2, and then while this powers from 2 to 3. And basically, it depends on what component we are using here. In this case, we're using a repeater. So 1 to 2, 2 to 3. So we have to make sure that for the pulse at 2 that powers the middle piston, it has to be fired earlier than the depowering of the top piston at 2. And we can secure that by using a repeater, because a repeater has a higher Tautic priority than an observer, which has a Tautic priority value of 0. This has a Tautic priority value of -1. And -1 is higher than 0. Yes, that's how it works. So, yeah, there you go. So, anyways, so that explains the importance of this circuit here. It's a very nice find, actually. Now to explain a bit more. So, let me just take out some signs. You see that when we fire this, this basically is, 1 and 4. This is 2 and 4. Right. And then what about, this dust here? Now this dust, if we recall from this here, it's supposed to, power this level 1 tick after this, and power this level 2 ticks after this. So this actually does both. So hence, if we see from here 1 means 2, and 4 means 6. So this is 2 and 6. So you will see that this is 4, right? The repeater. And this is 6. And this is the 2 pulses received by the middle piston at this location. So you can see that that's why it dirts. Like so. And let's see if I can mimic this. And the good thing about also relying on this dust to power this block is that during the retraction, it does this. And the same thing happens. It's due to piston priorities, racing condition, whatever you want to call it. So essentially, because this is power F4 and this is power F6, this means that the front piston will always have the priority to grab the block rather than the middle piston. So yeah, that's why this happens. And then all we need to do in remaining is just to time these 3 pulses accordingly. Which this here is done separately by here, and then this here is done by reusing this piston as well. So just this. So yeah, very nice. And now to explain the whole picture now. So I'll remove these signs because these aren't the correct timings because we are powering this dust line at 5. So if we examine this detailedly, what we need to do is that we power this at 8 and 11. I should indicate close. 8, 11. Opening would be 7 and 10. So it's the same as this here. Because this is also what controls the double. So it controls the triple here as well. Okay. And what about this here? So the close, it would be also, I should specifically say, it's the repeater on the right. So the close, it would be 9. Yeah, it's a bad number. Anyway, opening, it would be 8 and 10. And then for this dust here, yeah, it's a bit more annoying. So 8 and 11 means 9 and 13. And then opening is just 1 tick less, so it will be 8 and 12. And now what we need to examine is how we can facilitate, both the closing and opening. So as we have established, the closing does this, and then this will also retract this. But then we don't want to do that. We want to have this extend by powering this. So we can do that simply by powering this at the same time as to 13 here. So that's why there is a circuit that we need to fire at close during the closing at 13, which is here. And for the opening, because every single block retraction the first block retraction happens at 8. So, we need an 8 here. So opening would be 8. This will do its thing at 10. This will do its thing at 12. And notice that when we do this at 12, we can also have the top to do things at 12 as well. And this, it works because, 10 is here, so we can just add 2. So 12, it will work here as well. And this is also at 10, so, this middle piston is at 10, so adding to 12 and the top piston can retract it. And this is only required by the opening, but then we can also add it during the closing. And, if we can add that at the closing, why not? And then we want to refire this piston here only at the opening. So this piston can push at basically 14. We're doing increments of 2. So this means that this repeater has to fire at 14 and 16, which it will do that from here. So this is also means because this is a 2-tick delay. So this means opening, it will fire at 12. So 14 the first pulse and 16 at for the second pulse. So yeah. So this also means that the triple will fully retract at 17.5 if using 0.15 second rule. So yeah, so hopefully this makes sense to you, and you can also just basically count the delay for this. So this is, I say, open at 12, you can verify at 5, 6, 7, 8, 9, 10, 11, 12. And then for here, it would be, for the closing, so 5, this is a 2 ticks, 6, 7, 8, 9, 10, 11, 12, 13. For the opening, this is 3 ticks for the retraction, so 5 plus 3, 8. So, yeah. And then for the 12 on the top here, so 5, 6, 7, 8, 9, 10, 11, 12. So, yeah, you see the exact same delay as described in this thing here. So, hence you see like this and like this. It basically works. And the animation is also correct. So yeah, so this explains the timings you need to know. And with timings in mind, we can start building the door. But first, we have to consider the inputs. We have already considered this input. And let's continue with the bottom, I guess. So for the singles, it's actually quite apparent. So, we have these 5 singles, 4 of them will be done by this, but then the last one cannot do it like this because we need to control the double retraction, the front piston at this level here. We are basically forced to have an observer here because, this block is occupied. So what happens instead is that we'll have an observer here. And the reason is here, not something, for example, like this, is because, these two are obviously at different delays. And we are going to have this that's here. And if you haven't noticed already, the extension and retraction are done by different circuits. So this does the extension only, and the retraction has to be done separately, which will be done by this observer here. And similar for here. So we have this observer here. So these are all the inputs basically for the bottom. You can also add some inputs that are not that obvious yet. So for example, this bottom piston. So depending on how you wire the circuit, you can, for example, have it like this, or you can have it like this. So it just depends on how you wire the circuit. And in here, when we are planning inputs, it's not that necessary. We are only concerned on input blocks that are basically fixed. So for blocks that aren't necessarily fixed, we don't really care. So these are going to be the bottom ones. For the side ones, the right side specifically, as we have established that we are going to use, the dropper and then an observer like this, we'll have this basically, and we are also going to plan to have an observer here, although it's not entirely obvious if that will be exactly the case. And then for these 3 pistons, it's quite simple. We will have this here, and then depending on how we are going to wire the door, it will be either this or this, just depending on how you wire the door. But then this is absolutely necessary. And alternatively, you can, consider a solution where you can have this, but then usually it's not going to be the case. And for the double here, let's consider the front piston first at this level. So this is actually in unison with the singles here, so we can group them all together because they're all going to be powered at 8s with just a solid block. We currently don't really have much idea on whether we should put it here, or we should put it here, or we should put it on top like this. But yeah, just place a solid block would indicate that we do need to power block to the solid block. And then for the retraction of this piston here, it's going to be here basically. You cannot do it with a solid block because it interferes with this here. So an observer it is. And this here will be a different circuit. Yeah. And I'll show you that later. And also considering on the retraction of this piston, it's very obvious that we'll do this at here. Because there's no other way. If we do this here, we interfere with this here, which is not what we want. So yeah, so there you go. That's the size. And then these 2 pistons are not that known yet. So we'll just leave it out. For the top, we are going to use this dust here so that we can power both these 2 pistons simultaneously. We're also going to use this block here because we have the triple setup here. And then we also need an extra block here, to fire from here, basically. Although not entirely obvious, we can, do something at here as well if we really want to. And then for these singles here, all of these 5 can be controlled together by a dust line that works like this. Also, I should add this dust here. So this will power these 2 and also powers this one. And yeah, going back to the singles, we can do this here. And notice this is a solid block because we can also quasi-power the piston at this level. So yeah, but then this also means one thing is that these 2 pistons are both going to be controlled with just this space, which we certainly can. We can just have one observer here and it can do all the extension and retraction we need. It's actually quite simple. So yeah, we don't have to really worry about this block being used. So we're going to have this here because it's necessary for the triple this level. Now going to the left side, these 2 aren't obvious. What is obvious is these 2 pistons. We do it by this. And then the doubles are also quite obvious because we want to group them together whenever we can. So we can do things like this. And then depending on the context, we can control it by here. And which certainly will be, to be honest, because controlling here is quite troublesome, for example. And now going to here, the singles is a bit tricky because we have to consider this double here. The double, this can only really be powered by here. And while you might attempt to have an observer here, we need to notice that this retraction here cannot be done by this here because it interferes with this one. So it has to be done here. So having an observer facing these 2 would interfere with this here, so it doesn't really work. So the only solution really is here. It cannot be here as well because we need to control the retraction of the doubles here, which actually the input, it looks like this. So that's that. And yeah, that's basically going to be all the inputs. So yeah, these are basically the things that you need to think and plan before you actually wire the door. This is important that you notice which inputs are absolutely necessary and which inputs can be, decided just a bit further when you're building the door. Or otherwise, you might stumble upon some occasions where you basically have to redo the entire door or entire portion, which probably you don't want that. So yeah, our input is going to be at this block here. And the input circuit also has in conjunction with a bunch of other common circuits. So just going to build that now. So, and since we need to basically deliver the signal upwards basically without delay, so relying on dust means that we need to, make the signal strength strong. And the best way to do that is, to use instant repeaters. It can maintain the instant delay, basically. So it can go on top, and it can also increase the signal strength. And also another thing that's important is that it can resolve all input bug issues. Because if you're directly detecting from the input line, if you're not cautious enough, say you have a conjunction of pistons and non-piston components, then you would face input bug because a direct input and a repeater input will cause different delays for these 2 kinds of components. So yeah. So we'll start off with this here. Then hopper here, like so. So we start off by wiring this at 1, so this observer will be at 2. And the way we do that is with this here. And then also some common circuitry here, which will be handy later. So one here going to the sus line on top and it goes to here. So this will be at 2. We need to power this at 4. And the way we do that is a bit funny. We do 2 observers here, so this is now 3. We take 2 rails going down to here, and then an observer here. You might think there are alternative solutions, for example, solid block and then a 1-tick repeater. But then there are actually other components that will be here. And if you power them, it will interfere with this observer. So that's not what we want. And hence we have this rail solution instead. So this is control F4. And then we need this at 6. Now this is the only problematic part for the 6 and 10. Now normally for when you see 6 and 10, you would think of some easy solutions like an observer to a vortex and an observer. So that creates 6 and 10. But then here, we really can't do that because we don't have that much space to create a vortex and then instantaneously deliver to this piston here. In fact, just using 2 observers already obsoletes the delay. So we have to do it quite differently compared to others. And the way we do it is via this observer to 2-tick. So now it's 3. So 1 observer here, it will be 4. 2 dropper, 5, 6. Like so. So this is 6. And now we need the extra pulse at 10. So yeah, we will keep that in mind. But we first also have to deal with this here. You need to power this at 7 so that this powers at 8. And the way we do this is with this circuit here. So this is 3 ticks already. 4. Going to remove this. It actually doesn't matter. Like so. Now 3, 4, 5, 6, 7. So this is at 8. And then what about this at 10? Well, we actually already solved it due to other circuitry. 3, 4, 5, 6, 7, 8, 9, 10. So we are using the same circuitry, and they both all converge to this dropper here to power this. And one is at 6, one is at 10. So yeah, so that's basically that. And meanwhile, there's also something that powers at 8, don't forget, is this observer here. It's a bit tricky. The answer is actually a solution that seems not working, but it actually works. So we have this. 1, 2, 3, 4, 5, 6, 7, 8. So this works. But then you might think, won't this, interfere with this piston? The answer is no, because this piston is here from, so this piston is at here at 6. At 7, it will retract here, and then it will only be able to push from 8.5. But then this 2-tick repeater only powers from 6 to 8, so it's fine. So that's that. And we need to power this piston at this level at 12. So how do we do that? Well, we don't really need a toggle here. We can simply just add 2 ticks of delay from this observer to here. And 1 at 6, it doesn't matter. The pulse that matters at 10, so 11, 12. So yeah. And then we need to control 14 and 16. we'll do that a bit later. Yes, we will need to complete a bit of the side circuits, which we will do now. So extend our circuit to here. The circuit that will do the 14 and 16 is from the circuit that controls the singles. So recall that the singles have to fire at 8. So this is 8, 7, 8. And for this here, a similar story like this. So 8, 9, 10, 11, 12, 13, 14. So we need to have power this at 16, so this at 15. So what we do is here. So this is 9, 10, 11, 12, 13, 14, 15. This also creates 2 pulses, which is necessary for this piston to retract this piston to reset it. Now, I think it's important to note one thing, because this happened in the previous version, or during the time when I built it. So previously, I have this solution. That's a Dustia 46. It's also 46 of delay, right? So it should work, but then the thing is, if you are powering this with a long pulse, this piston, when arrived here, it can only extend 3 game ticks after. Whereas if you do things with a short pulse, so an observer, for example, observer has a 1 tick pulse or 2 game tick pulse, which means that this piston here can fire after 1 tick or 2 game tick, which is very important because we need to keep the animations of all of these pistons in sync. So yeah, not only the animation, to be honest, but also the timings, because if you push it to here, it can only power 16.5, then that's not nice. So yeah, that's why it's important that we have a 3 tick and an observer instead of just a 4 tick. So yeah. Okay, so while we're at the sides, let's complete this here. We said we need an offset such that it powers at 8 and 11 during the closing and 7 and 10 during the opening. So the offset is done at here. 3, this closing adds 1. So 4, 5, 6, our redstone lamp. 7, 8, and redstone lamp does 11 as well. So very nice. So we need 12 at the front pistons. We don't need a toggle because it only concerns on the piston at this level. It will not interfere. And for this piston here, it's just this. And we can count it. 8, 9, 10, 11, 12. So yeah. For this here, it's fancy. Because there are going to be some circuits that will occupy the space, we don't really have that much space to work with. So we can try to develop a solution that, basically connects 2 ticks off from this here to this here. So quite similar to the situation you see from this here to this here. But the solution would involve something like this, which is actually quite bad in 2 ways. For one, this observer is going to pulse the slab tower and have 2 extra pulses that will go to the top, which is not what we want. And we can resolve this actually pretty easily by this. But then here comes the second problem. This dust line is going to, get powered by the redstone block, right? So this dust here will power this piston and basically blocking everything to extend. And we don't want that. So we do need a toggle. And our toggle is done by this. It's quite simple, actually. And even though this dust here and this redstone block here, so this redstone block leaves at the same time as this dust powers, they're both at 0, but then it's actually fine. This is the same logic as to how instant repeaters work. When this redstone block leaves, this piston will retract. And retracting this block, pulsing this to 0 tick, and only then the redstone block will arrive to this position here and power this dust. But since this piston is already retracting, it won't instantly extend at 0. So it's the same as to here. And the difference between this piston and this piston is that this piston, it will re-extend, but this piston never. So that's how you do the toggle. So yeah. So that's two things were solved by this dust here. And this dust really does nothing during the closing. So let's just extend this to here. We need this at 2, this at 4. The solution is actually very simple. This is 2. This is 4. 2 and 4. There you go. We need this at 6 and 10. So remember, observer, 4 tick, observer. Just do observer, 4 tick, observer. We need to power the singles on at 8, as well as, the end rod front piston. The way we're going to do this is going from here. So 6, 7 from the observer, and then 8 to here. We need to control this at 12. And a smart way to do this is just a piston here and observer just like this. The reason this works is that because the singles are going to all power at 8. So this is powered at 8, 9, 10. But since it's a double pulse, so it will, besides 10, it will also give us a pulse at 12. So yeah, that works. So that's the right side almost done. We need 14 and 16 here, which is controlled by the top. So let's just do that. Top, on this side, it controls not that much stuff. So we have 5 here, 6, 7, 8. So 8 will power all the front pistons. Sorry, all the singles. And then modify this a bit to this. So 9 here, 10, 11, 12, 13, 14 to this. So 14. And then you guessed it, 15, 16 to here. So his bar is quite boring, as you can see. And then for this side also controls this blockade. So we need the offset first, which we do it now. We have this here, observer here, and then the circuit you've seen before. So we have, a redstone lamp, observer that powers both of those stuff. And we also have this here, and then remember this has to be a repeater. So, and on this side, there are 2 more things that we can control. We control this dust here. So for the first pulse, it needs to power 1 tick with a 1 tick delay, but then for the second pulse, it needs to power with a 2 tick delay from this dust. So this also means we need another offset circuit. And this time we do it differently. We do it with the circuit that looks like this. Now, how does this work? It's actually also quite simple. When this resin block is extended to this position, this means that the hopper is going to be depowered instantly and to repower after some delay, which we don't really care. And this means that this has 0 delay, and only delay is caused by the observer, which is 1 tick. But then for the retraction, because this is fired by a 1 tick pulse, so the piston can only grab the resin block really 1 tick after. So after the depowering, so at the depowering of the resin bus. So this means that it induces a 1 tick delay to this hopper already. And then another tick from this observer, so 2 ticks. So there you go. So that's another offset circuit. And remember that we are going to fire this at 12 during the opening. We can do that from here. So this is 5, 6. We're detecting from this position. So 9 already. 10, 11, 12. So that's done. So yeah, so that's all the things the right side will control. Then we come back to the bottom here to finish our circuits. So the same instant repeater is also at this location. And this time we're going to have observer and hopper like so. Now first we deal with this here. This is 8 and 11 during the closing and 7 and 10 during the opening. So we have the offset circuit, but this time it looks like this. And then we have this like so. So for the closing, so this is 1, 2, 3, 4 to this lamp here. So 5, 6, 7, 8. And then the opening, instead of 3, it'll be 2 for this here. So that's why this is 1 less tick of delay. So, which means the dust here will power at 7 and 10 instead. So, nice. Oh, also, by the way, I think I haven't talked about offsets yet. So you can see there are multiple examples of offsets. So this is one kind of offset for a 1 tick offset. 1 tick offset here. And then, you know, a 1 tick offset here as well. So these are the common 1 tick offsets that you will encounter. But then you might think, what about 2 tick offsets? Well, the solution is quite simple. Redstone lamp, observer, just power with a constant pulse, done. Because redstone lamp turns on instantly, but then turns off 2 ticks after. So that is a 2 tick offset. Anyways, now we're going to need the doubles to retract, you know, this at 12. And this can only be powered during the opening, so we need a toggle. And the toggle we are using is very funny. It's this. So to explain how this circuit will react, this dust will lock this dropper already during the closing. And to be honest, this piston doesn't even retract the redstone block during the closing because it's constantly powered by this dust here. So nothing happens during the closing. This dropper is still being constantly powered. And for the opening, first off, this dust turns off. This redstone block will get retracted. So as this redstone block, it will all get retracted. So this dropper will depower. And the last thing that depowers it is actually this redstone block. So there's no input bug issue. It's not this dust that will depower this dropper. It's this redstone block that will depower the dropper. And then the observer would spit this redstone block back out, such that the entire circuit is reset. And then we will connect to a 3 tick here. It seems quite awkward, but you'll understand it eventually. So we just build our circuit here, and the circuit is to use rails again, like so. And this also explains the reason why this here has to be rails instead of a solid block and then one tick repeater, because it will power this power rail here. So okay, so let's just count the delay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 and 12. And 12 is the pulse we need. 9 is the pulse we don't need. But then it doesn't really matter that it powers at 9. Because if we recall, we need this at 7. So powering at 9 doesn't really hurt because it cannot really retract the front piston even. So yeah. So there you go. 9 doesn't hurt. So we can do that. And notice that this entire circuit is 9. We can also do that here actually. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, it's the same logic basically. So let's just complete this bottom here. So we need all of these to power at 8. The solution is from here to observers, a dropper here, and then just observer line. And then eventually you reach this here. And for these to power at 8, well, divert it to here, like so. The optional item is here. It's not necessary. So yeah. And then we need to control this 14 and 16. Well, first we should control 2 and 4 first. So this is 2 and this is 4. So 14 and 16, it relies on another circuit. Relies on this. So 6 here. We are using the retractor position. So it's the second pulse that matters. So 6, so 10 because of the 40 pulse. 13 to here already. So 14 will power this. 16 will power this. There you go. And then while we're here, remember observer, vortex, observer. Yeah, it powers this piston actually. So yeah. Now we will work on the right side. Sorry, the left side. So first off, we want to fire the singles at 8. So we can do 4, 6, 7, 8. But now this is annoying. We need this at 8. So the thing is, we cannot use something like this. The reason is similar to the reason why you need some circuit like this to facilitate for the double extension and retraction. Because this piston can retract this piston. But if we are in this setting, we actually don't want this. Because what it creates is that hopefully this works. Yeah, it does this. Because by powering through this hopper, this 2-tick pulse to this piston can actually retract the front piston and not have the front piston getting extended back here. So we don't want that. But what we can do is do something like this. Now this in the traditional setting is not what we want because this cannot retract, but this is what we want here. We don't want it to retract the front piston. So we can do something like this. Yep. So that's our plan. So hence we have this. And to connect it is quite simple because this is already 3 ticks of delay. We just need 5. So, just give 5 ticks. Simple enough. And while we're here, we also want to control these singles at 8. So 5, 6, 7, 8. And then using the same trick as to here, we can connect it like this. So 8, 10, and 12 will retract this. So, and then now we'll do this here. So 8 and 11 for closing and 7 and 10 for the opening. So let's just create our offset first. Offset looks like this. We have a rest lamp here and going back down here. And you can verify this is 8 during the closing. So 4 here, 5, 6, 7 from this circuit, 8. So, yep. So that's that. And yeah, that should be the left side. And now for the top, 2 and 4. So 2 is controlled by circuit here. So 1. Sorry, this should be this 2. 4 is controlled by a circuit here. Like so. So 3 tick repeater and then 1 observer, 4. Okay. So on this side, it controls some other stuff. So say, for example, the closing 13 and the opening 8 are all controlled on this side. Because this is the only dust we have. So let's control the 13 on closing. So we take output from here. So this is 7. So this is 8. 9, 10, 11, 12, 13. And for the opening at 8, we have from here. So 1, 2, 3. So this is 1, 2, 3, 4, 5, 6, 7, 8. So there you go. Now we want to control this at 3 different pulses. We want this at 6. We want this at 10. We want this at 12. Let's control 6 first. 6 is as simple as this here to here. 1, 2, 3, 4, 5, 6. And then 10 and 12, well, if we actually 2-tick this piston, it will create a double pulse at 10 and 12. We can use this idea. So we take it from here. So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and consequently 12 due to 2-tick to piston. And on this side, there are 2 more things to control. One is 12 at here. One is 14, 16. So 12 is simple. This is at 8, right? So 9, 10, 11, 12. The second thing is, this at 14. So while we're here, so this is 10. So with the 2-tick repeater, it will be 12 now. And then 13, 14. And then the last thing is this at 60. So 10, 12, 13. We need 3 more ticks of delay. So how can we do that? 1, 2, rails, because we can. 3. So that's 60. And if I haven't messed up anything, this should be the door. Assess it. Let's see the front side. Looks good, I would say. And except we haven't finished this here, which is fine. Small mistake. So we are missing the 12 here. So we get it from these singles. So 8, 9, 10, 11, 12. So there you go. So yeah, that is the entire door finished. So, do the set block command. And, might as well look at this in slow motion. So to see that is in fact fully in sync. And we might as well look at the back side. And can look closer on the double and triple. So yeah, so that is the entire doors tutorial. The tutorial is just simply for you to follow on how the wiring is, according to timings. But if you just want to take a look at this door, I'm not going to post a road download from now on. Instead, I'm going to post probably a Lightmatic file. So it will act as a replacement of road downloads. So yeah, anyways, so thank you for watching the tutorial / explanation of the door, and I'll see you in the next video.